Good morning, everyone. So for this video, we'll tackle about the logarithmic functions. The logarithmic function to the base a, where a is equals to 0 and a does not equals to 1 is defined. So a is equals to log a x base a if and only if x is equals to a the power of y. When you convert the exponential to log form, notice that the exponent in the exponential becomes what the log is equals to. So convert to log form. 16 is equals to the square root of 16 is 4. Then log 4, 16 is equals to 2. They convert to exponential form. So log 1a to the base of 2 is equals to negative 3. Negative 3 is equals to 1/8. Log is equals to exponent. With this in mind, we can answer question about the log. Log 216 is equals to 4. This is asking for an exponent. What exponent do you put on the base of 2 to get 16? 2 to what is 16? Log 3, log 19 base 3 is equals to negative 2. What exponent do you put on the base of 3 to get 19? Log 1 base 4 is equals to 0. What exponent do you put on the base of 4 to get 1? Log 33 base 3 is equals to 1/2. When working with the logs, rewrite any radicals as rational exponent. What exponent do you put on the base of 3 to get 3 of the 1/2? So example number 1. Solve for x. Log x base 6 is equals to 2. Solution. Let's rewrite the problem in exponential form. So 6 squared is equals to x. We are finished. Example number 2. Solve for y. Log y all over 25 base 5 is equals to y. Then the solution is to write the problem in exponential form. So 5y is equals to 1 all over 25. Since 1 over 25 is equals to 5 minus 2. Then 5y is equals to 5 negative 2. Then our y is equals, divide both sides. 5 divided 5 cancel out. Then y is equals to negative 2. Finally, we want to take a look at the property of equality for logarithmic function. Suppose b is equals to 0, greater than 0, and b does not equal to 1. Then log x sub 1 base b is equals to log x sub 1 base b if and only if x sub 1 is equals to x sub 2. Basically, with logarithmic functions, if the bases match on both sides of the equal sign, then simply set the arguments equal. Example number 1. Log the quantity of 4x plus 10 base 3 is equals to log the quantity of x plus 1 base 3. Since the bases are both 3, we simplify set the arguments equal. So 4x plus 10 is equals to x plus 1. Then 3x plus 10 is equals to 1. Then 3x is equals to 9. Then x is equals to negative 3. Example number 2. Log the quantity of x squared minus 14 base 8 is equals to log 5x base 8. Since the bases are both 8, we simplify set the arguments equal. X squared minus 14 is equals to 5x. Then factor out x squared minus 5x minus 14 is equals to 0. Then x minus 7, x plus 2 is equals to 0, which is x times x squared. Then, and so on. X minus 7 is equals to 0, or x plus 2 is equals to 0. So, x minus 7 or x minus 2 it appears that we have two solutions here. If we take a closer look at the definition of logarithm, however, we will see that not only must be used possible basis, but also we see that the arguments must be positive as well. Therefore, negative 2 is not a solution.